Okay, so last time, ito eh. Okay, so for this chapter, part 2, we're going to talk about thermochemistry. So basically, we define thermochemistry as the chemistry of chemistry involving heat transfer or energy transfer, no? Okay, so ito yung coverage ng part 1 natin, part 2 natin. So we had an introduction to thermodynamics last time. And then we will proceed with the first law of thermodynamics and heat and work. So hanggang dito lang tayo because the other two will be discussed on a synchronous mode, no? Okay. So anyway, so last time, recall lang natin, we said that thermodynamics is the study of energy conversion, no? So this is evident in our daily life, no? For example, ito hawakan ko pencil ko. Ayan. So, anong energy meron dito? This is potential. Pero pag binitawan ko yan, kinetic na. Okay? So, from potential to kinetic, no? Ibig sabihin, may thermodynamics doon. Okay? May energy conversion. Okay? For example, itong lamp ko. Wala akong ring light eh. Ayan. So, itong lamp ko. So, chemical energy na sa battery niyan pag binuksan ko, naging light na, no? And medyo mainit 'yon. So, I can say na may heat energy, no? Okay? So, naging light and heat yung ating energy. What else, no? O tayo, yung kinakain natin, nag-breakfast kayo kanina, no? Kung hindi kayo nag-breakfast, kain lang kayo. Don't hesitate to eat during the class time. Wala rin kayo, kumain kayo kanina. So, yung chemical energy sa food, na-convert nyo yun uh, into work, no? So, gumagalaw kayo eh. So, yun. And heat as well, no? So, yun. So, yun. Yun yung thermodynamics. Basically, yung aaralin natin for the next few meetings, no? The conversion of energy from one form to another. Okay? And we defined energy last time as the capacity to do work, and work is the change resulting from a process, no? Okay. So ganito talaga ka-vague yung idea ng energy. Sabi niya, ang energy daw basta may gumalaw, okay? May gumalaw or may ma-transfer, may energy doon, no? Okay, and the work is the directed energy change. So for example, yung mouse pointer, galawin ko yung mouse pointer, may work doon. Okay? So ganun. Yun lang, no? So, ito yung mga uri ng basic work, basic forms of work noong high school tayo. So, we have the potential energy, and then we have the kinetic energy. Potential energy is the energy at rest, no? Okay. Meaning ng potential, ibig sabihin it has a potential to change, no? Okay, so this is the energy at rest, no? If you do something about this, no, magiging kinetic energy siya, no? And then also, ang ating molecules on this picture, sabi ko sa inyo last time, this shows the oscillation of molecules, no? Kaya umiinit yung mga bagay. So when the molecules vibrate, no, or oscillates, yun, umiinit. Yun yung concept ng microwave, no? So sa microwave, lagay mo yung food mo doon, then there will be enough, microwaves, literal na microwave yung nandun sa loob ng microwave. Okay. So yung microwave, maglalabas siya ng microwave that is enough energy to vibrate the molecules of the food. And since nagba-vibrate yung molecules ng food, umiinit yon. Okay? So one example to think of that is yung kamay nyo, pagdikitin nyo, okay? Tapos galaw-galaw nyo. Parang ganyan na nangyayari sa molecules, no? Naggagalaw-galaw yung mga molecules. So what will happen? Umiinit yung kamay ko kasi ko siya eh. Vibrate, no? So yun. So, ganun din yung mga molecules natin. So, when molecules vibrate, they produce heat energy. Okay? And yan, maraming ang uri ng energy. One example is the solar energy. And we can convert that to electrical energy. And that is used to power houses. No? even villages, no? And we have nuclear energy, okay? So nuclear energy, we have the chemical potential energy, okay? That is converted to heat energy, okay? So what happens in nuclear power plants ay ganito lang, you have your atom, and yung atom, nag-split yon into many forms, no? So pag nag-split yung atom into many forms, may energy na ilalabas siya in the form of heat. And that heat can boil the water, no? Yung water, pag nag-boil yon, it can turn into gas, no? And then yung gas na yon, ipupush niya yung generator, okay? So yung boil, 'di ba pag nag-boil yung water, hangin yon. Okay, so air, ano na yon, water vapor. And that air can actually push the generator. So pag umikot-ikot yung generator, magiging kuryente na. Okay? So basically, ang process sa nuclear power plant is from chemical potential energy to heat energy to work, no? Okay. So ganun. So from molecules, from atoms, mag-split into smaller particles. So iinit 'yon. And then yung water, absorb yung init, tapos magbo-boil up siya. And then yung water vapor, itutulak niya yung generator. So ang daming thermodynamics na nangyari doon, no? Ang daming conversion ng energy, no? So ganun ka-complex ang nuclear power plants, no? And then we have also the matchstick, no? Burning. So basically the phosphorus compound in posporo, kaya nga siya posporo tawag, may phosphorus kasi doon. Okay? So on the in matchsticks, no, we have phosphorus, kaya Tagalog niyan is posporo, no. So pag in-struck mo 'yan sa gilid ng box niya, okay? So it provides enough heat, no, to kickstart the combustion of the material in there, no. Kaya 'yun, nasusunog siya. So that is from chemical energy to heat energy and light, no. Yan. And also may work din kasi as you can see may gas na gumagalaw, no. So, pwede niyan itulak yung molecules above it, no. So may work din diyan. And yun nga, sabi ko sa inyo last time, we are focused on the energies produced or absorbed in chemical reaction. And that study is called thermochemistry. No? Ito yung focus natin ngayon. Okay? Now, let's go through some terminologies. No? Pasok muna tayo sa ilang terms that we need to know sa thermodynamics. No? So, suppose we have a chemical reaction happening inside a beaker, no? Kunwari, may beaker tayo. Paghaluin mo yung dalawang substances mo doon, may chemical reaction na nangyari. Okay? So, yung beaker na yon, that is called the system. Okay? Sa thermodynamics, ang tawag doon ay system. Kung saan nangyayari yung chemical reaction. For example, kumain tayo. Tapos yung pagkain natin, dinadigest ng katawan natin. Ano yung system? Ito yung katawan mo mismo. Kasi doon nangyayari yung mga chemical reactions eh. Okay? And then, may interaction ang system with the outside world. Okay? So, ibig sabihin yung system, nag-interact siya with the outside world. Ano meaning nun? Okay. So, kunwari, yung ating dinigest na food, ano mangyayari doon? Some of that energy will be released sa body natin, no? In the form of heat, no? Kaya nga mainit tayo eh. Especially pag may lagnat, 'di ba? So, yun, may interaction yung system with the environment, no? We are releasing energy from ourselves palabas, no? Okay? Basically, kapag may lagnat ka, lumalabas yung chakra mo. Lumalabas yung energy mo, no? So, ibig sabihin, may interaction yung system and the surrounding, no? So, let's imagine system as the circle. And then, outside is the surroundings. Siyempre, mapapansin nyo, may boundary dapat yan, yung system and the surroundings. Hindi pwedeng walang boundary yung system and surrounding, no? Okay? So, may boundary yan, no? Kahit wala yan sa beaker, no? For example, tubig lang yan na nilagay mo sa lamesa. Pinagalo-halo mo mga chemicals doon. May boundary pa rin doon. Yun yung liquid layer. Okay? So, ibig sabihin may boundary na. Okay? Boundary. Okay? So, ito yung parts ng universe, no? Pag kinuha natin 'tong lahat, itong bigger picture. We call this the universe, no? Medyo familiar ba sa inyo sa math 'yan? Kasi sa math gano'n, 'di ba? Okay, wait lang. 'Di ba sa math meron tayong ganito? Yan. This is the universe, no? And this is your A, this is your B, no? And everything else is universe. Okay? So, ganun din sa thermodynamics. So, yung nasa loob ng circle, that's the system. Okay? Dito nangyayari yung chemical reaction. Outside this system, ando yung surroundings, no? And pag pinagsama mo yan, you have your universe, no? And the thing that separates the system and the boundary, the system and the surrounding is called the boundary. Okay? Okay, system, boundary, surroundings. Okay? So, depending on the boundary conditions, we can have different types of system. Okay? So, bakit, no? Ang boundary kasi natin, either it could be diathermal and permeable. Pwede rin naman siyang impermeable and adiabatic, no? Okay? Or mixture of the two, okay? So, define natin what is diathermal, no? Diathermal boundaries are boundaries that can allow the heat transfer, okay? So, these are boundaries that allow the heat transfer. Bigay tayo example nun. Our body. Yung body natin, this is diathermal. Kasi yung init sa loob ng katawan natin, lumalabas siya. Nahahawakan mo nga, nararamdaman mo sa labas eh, 'di ba? O kunwari, pag may lagnat ka, 'di ba, sasabihin mo, "Uy friend," pag ganun, 'di ba nararamdaman niya yung heat sa loob ng katawan mo. Ibig sabihin, our body is diathermal. Another example would be yung baso. Okay, 'di ba pag may mainit kang tubig, lagyan mo yun sa baso. Mafe-feel mo mainit yung labas ng baso, 'di ba? Kahit nasa loob yung tubig. Because yung baso, that itself is a diathermal boundary. Okay? So diathermal boundary, those are boundaries that can uh, let heat to pass through. No? So pwede tumagos yung init doon. Okay? So basta makakita kayo ng diathermal, heat can pass through. Ngayon, ano yung adiabatic, no? So adiabatic boundaries are boundaries that do not let heat to pass through. Hindi niya hayaan tumagos yung init, no? Ano kaya example nun? Sige. Ano kaya example ng adiabatic boundary? Those boundaries that cannot allow, that would not allow heat to pass through. Okay. O anyone? Do you have any idea ano kaya yon in real life? Ano yung bagay na pag nilagyan mo ng mainit, hindi mo mafe-feel yung init sa labas niya?
Thermos, sir.
Ayun, thermos. Okay, so good. Ayan, so thermos, 'di ba? Lagyan mo ng tubig na mainit yung thermos. Pag ginawa mo yun sa labas, wala lang, malamig pa rin, okay? Pero sa loob, kumukulo na nga tubig nun minsan, 'di ba? Okay, so thermos is one good example of adiabatic boundary. Okay? So yan, so imagine natin diathermal baso, ang adiabatic thermos, no? Because yung thermos, it doesn't allow the heat to pass through it, no? Ang sasabihin niya, oh, you shall not pass, di ba? So yun, edi hindi siya sasabihin ng heat, edi don't, di ba? So hindi lalabas yung heat doon. Okay? So yun yung two types of boundaries in terms of heat, no? So they could be diathermal and adiabatic. Okay? So yan. When you say permeable naman and impermeable, from the word itself, permeable, ibig sabihin pwede mag-flow from one to another. Okay? So, bigay tayong example ng permeable membrane, permeable boundary, o yung baso. Pag walang takip yun, edi permeable yun. Kasi pwede ka maglagay ng tubig from the outside world to the inside of the baso. Pwede mo gawin yan, di ba? Dagdagan mo siya mainit ng tubig, saan mo ilalagay? Di dun sa butas ng baso. Okay? So, ibig sabihin, permeable yon. Pwede pumasok yung mga molecules. Pwede rin lumabas doon sa opening niya. Okay? So, yun yung opening, yun yung permeable boundary. No? Ibig sabihin, the molecules can pass through. Okay? Meron din tinatawag na semi-permeable in biology. Okay, so semi-permeable membranes are membranes that only pass through certain particles. No? For example, molecules of water, yun. Yun yung mga nasa cells natin. But in thermodynamics, basta nagpa-pass through permeable. Okay? So, yun. Another type of boundary is the impermeable. Meaning na kapag no, pag may prefix na negative 'yon. Ibig sabihin, hindi siya pwede mag-pass through. Okay? So, negative, no? Bawal lumabas. Okay? So, bawal lumabas by Kim Chu. Ganun yan, na? So, ibig sabihin, if we have an impermeable membrane, yung particles mo, they cannot enter nor go outside. Confined lang sila sa loob ng system. Ang example nun, o yung baso mo, takpan mo. Patungan mo ng ng aluminum foil o kaya patungan mo siya ng yung saran wrap, no? Yung pinambabalot sa food. Yan, patong mo yun doon. Yun. So, ibig sabihin, magiging na yun, magiging na siya, impermeable. Okay? So, yun yung definitions ng ating boundary condition. We have the diathermal, meaning nun, it can allow heat to transfer, no? Example nun is the baso. Pag nilagay mo mainit na tubig, lumalabas yung init, no? Mula sa tubig, palabas sa boundary ng baso. Okay, so, pwede yung heat flow. Okay? And then you have the adiabatic, which means it cannot pass through the water. So, hindi niya papayagan yung init mag-pass through. Okay? Example nun is the thermos. And then we have the permeable. Ibig sabihin yung particles pwede maglabas-pasok sa system. For example, yung baso mo, walang takip. Yun. Pwede mo ilabas-pasok yung mga molecules doon sa baso, which is our system. And then we have the impermeable. That means, basically, naka-close yung system. Okay? Nakatakip. Okay? So, yan. So, depending on the combination of the boundary, no, depending on the type of particles or energy that they can pass through, iba-iba yung tawag nila. For system that can pass through matter and heat, we call that an open system. Obvious naman, open yan. Okay? Kasi yung matter, pwede lumabas-pasok. Ibig sabihin, bukas, no? Okay? And the heat can also pass through. So, yan. We call the systems that are diathermal and permeable an open system. Now, if yung matter, hindi mo payagan lumabas, basically, ang idea nandun is nilalagyan mo ng takip yung system mo. Ibig sabihin, kung may open, meron tayong closed. Okay? Close, open. Okay? So, kapag open, yung matter pwede lumabas-pasok. Pag close, hindi pwede siya maglabas-pasok. Okay? Pero yung heat pwede pa rin, no? For example, yun nga, ka sa baso, takpan mo yun, pero mafe-feel mo pa rin yung init, lumalabas pa rin, di ba? Okay. Pero yung particles, hindi na siya lumalabas. Okay? So, closed system yun. Then, what if parehas niya pinipigilan mag-pass through yung matter and heat, no? We call that an isolated system. Okay, isolated. Meaning, excluded talaga siya from the outside world. No? Hindi siya pwede makipag-interact in terms of particles and in terms of energy sa outside world. Okay? So, one good example of that would be thermos. Okay? Mapapansin nyo sa thermos, kahit ilang araw na yung mainit na tubig mo dun sa loob, mainit pa rin siya. Okay? Kasi nga, walang interaction with the outside world, no? Pero kapag yung thermos mo, lumamig yan, ibig sabihin may sira yung, may sira yung boundary nun. Okay? And then you need to buy another one. Okay? So that's the idea about, about where the reaction takes place, no? Yun yung system. Okay? So alam natin that the system is separated from the surroundings by the boundaries, no? Okay? So the system is separated from the surroundings by the boundaries, and depending on the boundary type, we have different types of systems as well. Okay? So yun lang. So yun lang yung mga terms na you need to know. Okay? Now, there are also other terms which refers to the processes naman, the thermodynamic process. Okay? So when you say thermodynamic process, ito yung process in which the energy can flow. Okay? So in transferring energy, it could be an irreversible process or it could be a reversible process. No? Pag sinabing irreversible process, these are processes that are biglaan. No? Ito yung mga sudden changes. Okay? So, if we have a sudden change in our system, ibig sabihin nun, the system cannot go back to its original state, no? Okay. So, ito yung mga biglaang pangyayari sa system na hindi na siya nakapag-adjust, no? Nagulantang yung system, no? So, ibig sabihin, hindi na siya babalik sa dating form niya. Okay? So, irreversible process 'yan. And then reversible process, pag sinabi namang reversible process, ibig sabihin ito yung mga dahan-dahan lang, no? Okay. So dahan-dahan lang yung process from one point to the other point, and pwede bumalik 'yan, no? Mag-back and forth siya. Okay lang 'yan. Okay? So that's the reversible process. Mamaya babalikan uli natin 'to, no? Para mas ma-visualize natin. Okay? So sa ngayon, gawin niyo lang muna siyang floating idea. Pag irreversible, yan yung biglaang changes sa system. Therefore, the system cannot go back to their original form kasi nabigla siya. Pag sinabi namang reverse, ito yung slow changes. Okay? Stepwise change, no? Dahan-dahan. So that the system can adjust, no? And pwede siya mag back and forth from the original state and the final state, no? So later important to, no? Kaya let us leave this hanging. Other processes are called isothermal, isobaric, isochoric, and adiabatic. Okay? So when you say isothermal, when you say iso, pag sinabing iso, that is equal. Okay? Equal yung energy. Equal yung, pag sinabing thermal, temperature, no? Okay. So equal yung temperature. Ibig sabihin, walang pagbabago sa temperature, no? So there are thermodynamic processes that undergo isothermal processes, no? Ibig sabihin, nangyayari yung conversion ng energy na hindi nagbabago yung temperature. For example, itong lapis, anong temperature dito sa kwarto ko? Siguro 28 degrees Celsius dito. Okay. Tapos, bitawan ko yan. So that energy change is isothermal. Okay. So that energy change is isothermal. Kasi yung potential naging kinetic at the same temperature lang. Okay. So yun, isothermal processes are processes or changes that happen under a constant temperature environment. Next, we have the isobaric. Okay. Pag nakita nyo yung baric, meaning non pressure. Kaya nga barometer, pressure meter. Okay? Yun yung literal meaning niya. Okay? So isobaric processes are processes that occur at constant pressure. Katulad ng ginawa ko rin kanina, 1 atmosphere dito sa kwarto. Okay, yung potential naging kinetic in 1 atmosphere lang din. Okay? So that's an isobaric process as well. When you say isochoric process, ito medyo hindi to obvious. When you say choric, ibig sabihin nun volume. Equal volume or same volume or constant volume process. No? So, ito medyo specific na to. No? Medyo na to. About sa chemical reactions na talaga. No? So, wala akong mabigay na literal example na to for now. Ay, hindi. Meron. Meron akong mabibigay na example. Ano kaya yun? Kunwari, you mix muriatic acid, pati tubig, no? 5 ml ng muriatic acid, 5 ml ng tubig, iinit yun, di ba? Yung solution na yun. But the volume is constant, no? Tig 5 ml sila. Pag pinagan mo yun, 10 ml, no? Pag pinagalo mo yun, constant yung volume, same pa rin volume nila. Pero, may processes, no? Nagre-release sila ng heat. So, yan, isochoric process yan. Okay? So, yun yung example. Yun lang yung naisip ko for now. Okay. So again, we have isothermal, constant temperature, isobaric, constant pressure, isochoric, constant volume, and then the last one, we have the adiabatic process, in which there is no heat flow. Okay, o ganito. It doesn't mean na kapag walang heat flow ay walang temperature change, no? Is temperature equivalent to heat, no? Not really. Because we actually define temperature as the speed of the molecules, no? Okay, so we define temperature as the speed of the molecules, no? Speed of molecules yan. But that is not equal to heat, no? Okay? Yung temperature, yes, thermal siya. Pero yung thermal, it is not the heat, no? Not equal sila, no? Okay? Kasi when we say heat, ito yung flow of energy. Flow of energy. Okay? So, yan yung flow of thermal energy. Ibig sabihin, pwede ka magbago ng temperature without letting the energy flow, no? Okay? So, ganun yung nangyayari sa thermos, no? Yung speed ng molecules doon, hindi siya nata-transfer kasi. Okay? So, ibig sabihin, walang heat. Pero may temperature, yes, no? May certain temperature sa loob ng thermos. Ang kunwari, ang speed ng molecules ay 98 degrees Celsius, no? Ang speed ng molecules ay measured in terms of temperature. Okay? So, ang speed ng molecules ay 98 degrees Celsius. Pero, kapag hindi nag-transfer yung yung energy nila, walang heat, no? Okay. For example, ngayon sa thermos, gano'n man kainit yung nasa loob, basta hindi nagfo-flow yung energy, adiabatic yan. Ibig sabihin, pwede magbago-bago yung temperature even without heat flow. Okay, pwede gawin yan na. Although this is medyo complicated na. This is too complicated to be done in normal conditions. You really have to have special equipment to do adiabatic processes. No? So again, take note of this. Temperature is not equal to heat. No? Related sila, yes, pero hindi sila equal. No? Pag sinabi kasing heat, ito yung flow of energy. Pag sinabing temperature, ito lang yung energy ng particles. No? Pag ginalaw mo yung energy ng particles, doon nagkakaroon ng heat transfer. Okay? Energy transfer. Pero pag di mo ginalaw yung energy nila, temperature lang yan. Okay? So, walang heat kapag di ginagalaw yung energy ng particles. Parang ang weird isipin, no? Pero ganun talaga. Okay? So, medyo weird siya sa una, pero that's how reality works. Ganun talaga yung mga nangyayari sa ating bagay-bagay sa paligid. Okay. So ito take away natin to. So temperature, yun yung speed lang ng molecules, but it is not necessarily the heat. Kasi when we talk about heat, that is a process. Okay. That is a flow of energy. Okay. Pwede magbago to without having any heat, no? Hangga't hindi nagpo-flow ang heat. Okay? So, ganun. Ayun lang, yun yung mga terms ng processes natin which we will encounter later on, no? So, until the end of thermodynamics, until the end of chapter 2, ma-encounter natin yung mga words na yun. So, please be minded, no? Okay? So, kahit di nyo naman kabisado, okay lang. Basta familiar kayo sa terms. Okay yun. Okay? So, next one, we have the properties of system. Okay? So, ang properties of system ay intensive or extensive. Katulad lang din ng properties of matter. Okay? Kasi, ang system natin ay technically, parang matter lang din yan. Okay? So, ang matter natin may extensive and intensive property. Ang system, ganun din. Okay? So what are the extensive properties of matter? No? So when you say extensive, these are properties that are dependent on the amount of particles, no? The amount of matter present. No? So some example include volume, moles, internal energy, and entropy. Okay? So depende sa dami ng molecules yung amount ng extensive property. Okay? So for example, I have a solution. Ayan yung liquid volume niya. Tapos ito. Ito yung isa. So, sino mas marami? Obviously, ito. No? Kasi mas marami siyang tubig eh, no? So, sino mas maraming moles? E di ito. Sino mas maraming, sino mas maraming, ano kaya? Sino mas maraming moles, sino mas maraming volume, sino mas entropic, sino mas mataas internal energy. O basically, ito pa rin, no? Okay. Kasi since mas maraming particles dito, mas maraming collision, therefore, mas maraming entropy. Okay? So, since mas maraming particles din dito, mas malaki volume niya and the number of moles. Okay? And the internal energy, kwento natin to mamaya. No? Ito yung focus natin mamaya. Okay? So, ganun lang. Yan yung extensive property of matter. Okay? So, kung sino mas maraming particles, siya yung mas malaki yung value. Kung sino yung mas onte, siya yung lower in value. Okay? How about intensive property? So, for example, water yan. So, sino mas dense sa dalawa? I will ask you, sino mas dense dito? Ito, yung mas maraming tubig or ito? Sino mas mataas density? Assume natin parehas tubig yan. Sino mas mataas density? Yung mas maraming tubig or yung mas onti tubig? Sige.
Same lang po.
Same lang. Okay. So good, same lang yan. Kasi, it doesn't matter, no? Kung gaano karami siya or gaano siya kaonte. Because we know density, ano yan eh, constant yan, di ba, for a matter. So, ayun yung mga intensive property. Okay. Regardless of the quantity of matter, the density is always the same. Okay? So, how about temperature? Kunwari, ilagay ko yan sa oven. And yung oven ay naka 75 degrees Celsius. Sino mas mainit dito? Ito or ito? Or parehas lang?
Parehas lang po.
Parehas
lang din po.
Oo, kasi parehas lang, no? Kasi regardless kung marami yung particles or onti yung particles, no? Yung temperature ay same lang, no? Kasi nasa isang environment lang sila. Okay, so that means intensive property and temperature. It doesn't matter whether marami kang volume or onti lang yung volume mo, no? It doesn't matter kung ito 1 litro, ito isang patak, no? As long as nasa isang environment sila, they will have the same temperature. Okay? So same pressure, ganun din. O kunwari ito nasa kwarto ko. So what is the pressure exerted by the atmosphere dito and dito? That will be the same. Okay? Kasi same lang yung ano eh, atmospheric pressure, 'di ba? On a certain elevation. Okay. So yun. Yun yung difference ng extensive and intensive properties of matter. No? Again, extensive, it depends on the volume. Okay? It depends on the quantity of matter. So, kapag mas maraming matter, mas mataas yung kanilang extensive properties. No? O, mas madaming volume, mas marami yung moles, obviously, marami yung particles eh. Mas entropic, ibig sabihin, mas magulo. No? Kasi ang dami nila eh. No? For example, sa PUP, pag nagklase doon, 50. Okay? So, usually 50. Meron pa nga time na umaabot ng 70 yung isang class doon eh. Okay? Ganun ka-onti yung faculty sa PUP, no? So, umaabot ng 70 yung isang klase minsan, no? Ang gulo nun. Okay? Compare nyo yan sa sa Lasal, no? Sa Lasal, 20 lang. Maximum na yun, 20. So, mas hindi siya magulo. Sa FAU, ang klase namin 40 lang, no? Okay, so mas mahirap kontrolin yun sa PUP kaysa sa FAU and mas okay kontrolin yun sa Lasal kasi onti lang yung mga tao, no? Pag marami kasing mga tao, magugulat ka lang, mga estudyante nagbabatuhan ng papel, 'di ba? Ay nagdadaldalan, nagchichismisan, ayan. So, ibig sabihin mas onti yung particles, less entropic, no? Mas madali sila makontrol. Okay? So yun yung idea ng entropy, but we will discuss that in the future. Okay. Pag sinabing intensive property, these are properties of matter that are independent from the amount, no? Constant kasi sila. Either they are constant on their chemical property or constant sila because of the environment. Okay? So, meaning ng environment, kung nasaan sila, ano elevation nila, ano temperature sa paligid, yun. So, dun lang sila nagdedepende sa paligid nila and to themselves then. Okay? Another terms na gagamitin natin sa thermodynamic is the states of system. Okay? Puro terms lang tayo, napapansin nyo. No? So when we have state of system, these are values relevant to macroscopic properties. No? So kumbaga, these are values. No? These are values for the properties of system. No? That depends on the pressure or not. No? Medyo mahirap to i-visualize. No? Wala akong nilagay na picture. Okay. So anyway, so let's try to simplify the idea of the state subsystem. Pag sinabi nating state function, yung value nito ay same lang. Yung value nito ay constant regardless on how you achieve that condition. Pag sinabing path, depende to sa process mo. Okay. So I will give you an idea kung ano yung literal meaning nito. Kunwari may bundok. Okay. So this is point A, this is point B. Okay? Let's suppose the distance is 1 kilometer. Ganyan na lang. So ito, the distance from point A to point B is 1 kilometer. Tapos, yung tao, ginawa niya, nag-ikot-ikot siya sa bundok, then bumaba siya. So let's say ang travel niya ay 5 kilometer. So, sa example na to, ano yung state function at ano yung path function? Okay. Kasi papansin nyo, from point A to point B. Okay. From point A to point B, initial and final, 1 kilometer lang yun. No? So sa tingin nyo, what is the state function here and what is the path function? Yung state function is from the initial point and the last point lang. It doesn't matter kung saan siya dumaan. Okay. So kumbaga, sa example na to, yung displacement ay state function. Displacement. Kasi wala siyang pake kung saan siya dumaan, no? Sabi niya, regardless of how the condition was achieved. Okay? So wala siyang pake kung umikot ka sa bundok o kaya nagsasayaw-sayaw ka sa taas saka ka bumaba, no? So it doesn't matter kung ano ginawa mo in between. Basta initial minus final 'yon. Okay? State function ang ganun. Okay? It doesn't matter basta ma-achieve mo yung endpoint mo. Okay? So 1 kilometer yung displacement mo. State function 'yon. Ang path function would be the distance traveled, no? That will be the distance traveled. Okay. So yan. So it is the distance traveled, no? Kasi although ang displacement mo ay 1 kilometer mula dito papunta doon, pwedeng pwedeng ginawa mo, umikot ka dito, o kaya mamaya naggroto ka muna, no? O iba yung distance mo kasi syempre pag grotto, 'di ba, ang daming hinahakbang. Tapos bababa ka, tapos ikot ka uli sa bundok na. So yun yung path function. Depende siya kung paano mo ginawa yung proseso. Okay? Pwedeng nagdasal ka muna sa taas, tapos umikot-ikot ka, no? Okay? Kaya naghanap ka ng mga treasure dyan, no? Tapos saka ka pumunta sa point B. Okay? So, another example would be ito. Kunwari, ikaw, you are at point A. Then, ito yung PUP, point B. Okay? Ang distance ko mula sa PUP ay 10 kilometers, no? Valenzuela to Manila, 10 kilometers yan. Ay, hindi. 13 kilometers para. Yan. Alam ko kasi nag-Google Maps ako pag bumabiyahe ako papuntang PUP. So, yan. So, yung displacement ko from here sa bahay papunta sa PUP, 13 kilometers, no? Pero, yung distance na pwede ko i-travel, variable, no? Kunwari, pupunta muna ako ng SM North, no? Tapos pupunta ka mamaya ng Cubao. Mula sa Cubao, pupunta muna ako sa saan kaya? O sa Recto. Tapos mamaya pupunta pa ako sa Puresa. Tapos nasa PUP na ako. Ang dami kong inikot-ikot, no? So, that's more than 13 kilometers. O, pwede rin naman, dire-direkta na lang, no? Dire-direkta. Hakbang ako sa bubong, no? Pero alam nyo, hindi pwede yun. Hakbang ka sa bubong. Direkta yun. Yun yung state function. Yung direct from initial to final. And so, pwede iba-iba yung distance traveled ko, no? O kaya, in another day, ang aking ruta naman ay magje-jeep ako papuntang LRT. Tapos yung LRT, lumagpas ako, napunta ako sa Taft, no? Tapos mula sa Taft, pumunta ako ng recto uli. Tapos pumunta ako sa dorm. Hindi na ako nagdo-dorm, pero dati nagdo-dorm ako. Tapos pumunta muna ako ng Cubao. Tapos dumiretso na ako ng PUP. Okay, so mapapansin mo, depende yung value ng distance kung ano ginawa mo sa buhay mo, no? So, yun yung mga path function. Ang state function is, basta initial to final, yun. Ito yung value niya. Okay? So, yan. Important to later, no? Okay. So, yun yung idea lang, ha? Yung path function, depende kung paano mo ginamit yan, paano ka gumalaw, or ano trip mo sa buhay, yun yung path function. Ang state function is, basta na-achieve mo yung last point. Parang yan, parang student life lang din yan. It doesn't matter kung gaano ka katagal sa university. Pwedeng napatagal ka kasi bagsak-bagsak. Okay. Kaya napatagal ka kasi you have to file for leave of absence, no? You have to work muna, no? It doesn't matter. Pero yung state function doon, is ganito. It doesn't matter kung ano ginawa mo during your stay in the university. Mahalaga, makagraduate ka. Okay? Parang ito yung enrollment to graduation. Yan yung state function. Pero yung anything na ginawa mo in between, yun yung path function. Pwedeng yung first year, full-time student ka, second year, nag-work ka, tapos nag-work ka uli, nag-third year ka, habang nag-work, tapos fourth year, so yun, nakagraduate ka na. Okay? So, parang yung idea ng path function. Ang state function, mahalaga na achieve mo yung last point. Ang path function, yun yung processes na dinaanan mo to achieve the last point. Okay? So, ang buhay ay ang buhay state function yan. Pinanganak tayo, mamamatay tayo. Pero what matters is yung kung ano yung ginawa mo, ano yung path mo during that time, di ba? Okay. Yung state function kasi, dead end yan parate, no? Basta mamamatay ka in the end. Ang tanong, ano yung ginawa mo sa buhay mo? Yun yung path function. Ano yung path mo sa buhay? Ayun, ang kanya-kanyang trip na to sa buhay, no? Kasi lahat naman tayo, we are defined by state function. Lahat ng tao mamamatay. Pero yung ginagawa natin sa buhay, iba-iba, no? So kanya-kanya, wala tayong pakilamanan dito dapat, no? Okay? So yan, it doesn't matter kung matagal graduate or mabilis graduate, mahalaga makagraduate, no? Yun lang naman kasi, again, ang buhay, that is defined by state function. Dead end ang life, no? Pinanganak ka para mamatay. Okay? So, o kaya nag-enroll ka para graduate, no? It doesn't matter kung ano ginawa mo in between. Okay? So, yun yung states of system. Now, let us apply this concept sa main topic natin. Okay? Let's now proceed with our main topic, the first law of thermodynamics. Okay? So, let's talk about internal energy. Apply na natin to, ha? Itong concept na to mismo dito. Okay. So, internal energy is the total energy of system at equilibrium, no? So, for example, itong lapis ko na naman. Okay. So, ano internal energy nito? So, marami, no? May mga chemical potential energy, may potential energy, no? May motion yung mga molecules dito, so on and so forth, no? So, generally, we can describe internal energy as the sum of all the energies, no? Lahat ng energy na nandito sa pencil ko. O may battery to, no? Kaya ito yung ginagamit, charge ko to pag lobat So may battery to, ibig sabihin may chemical energy to, may potential energy. Tapos may kinetic energy din dito, yung mga molecules na ay yung electrons gumagalaw-galaw dito sa sa circuitry ng pencil na to. Kaya siya gumagana. Okay. So, yun. So, ibig sabihin, may potential energy dito in the form of chemical energy or the virtue of height, no? And meron din tong kinetic energy, yun yung motion ng particles in here. Okay, kunwari, galawin ko to, nagbabibrate yung molecules doon. Okay, so ibig sabihin, may mga kinetic energy yan. Sa tao, ganun din, no? Kunwari, ano yung potential energy ko? Yun yung mga chemicals stored in my body. Chemical potential energy yon. Okay, yun yung mga energy na nasa phosphate molecules, nasa glucose molecules, etc. etc. Ano yung kinetic energy dito? Yung motion ng particles ko. Okay? Kunwari, yung blood ko, nagfo-flow siya from paa. Tapos mamaya, yung blood ko nasa ulo ko na. Ibig sabihin, may motion yung mga molecules ko doon, may kinetic energy. O yung kamay ko rin gumagalaw-galaw, no? So, ibig sabihin, may kinetic energy doon. So, overall, when you say internal energy, yun yung sum talaga ng energy. Lahat ng chakra ng isang system. Yan yung internal energy. Okay? So, yun yung addition ng pag pinagsama mo yung kinetic energy and the potential energy. Yun yung overall energy or the internal energy. Ito yung problem. Madali ba i-measure yung kinetic energy and the potential energy? Madali ba yan i-measure? Ang sagot ay hindi. Hindi yan madali i-measure. Kasi kunwari, I want you to determine my internal energy. Ano gagawin mo? Compute mo. Ano yung height ko? Kasi for every particles at different height, iba-iba yung potential energy. Ano pa? Bilangin mo ilan yung molecules ko sa loob ng katawan para ma-compute mo yung potential energy ng chemicals. In terms of kinetic energy, lahat ng bagay na gumagalaw sa katawan ko, may-measure mo yung speed nun. For example, yung dugo. Okay? Yung hangin, no? Okay? So, yun. Ang dami mong kailangan i-consider when you are solving for internal energy. So, ibig sabihin nun, parang ang hirap, no? Kung titignan mo yung topic na to in terms of kinetic and potential energy, parang ang hirap niya i-absorb, no? Kasi, ang dami mong kailangan i-consider, no? Ang daming sources of kinetic energy and ang daming sources ng potential energy. But, there is another way, no? To simplify yung pag-solve natin ng internal energy. There is a shorter way for us to quantify that, no? Take for example yung battery. Okay? So, naglagay ako dito ng portable fan. Tapos ito, ginagawa ko to nung LM high school. You have the battery, you connect it, iinit to. Tapos pwede mo yung gawing magnet actually. Okay? So, ano yung relevance nito dito? Okay, kasi sabi natin, when solving for internal energy, ang hirap. Kasi ang dami mong kailangan i-consider eh. Kung hindi natin to gawan ng paraan, wala tayong madidiscuss na matino dito. Yung, kailangan mo i-solve lahat eh. Okay. Pero let's look at internal energy in other ways now. Take for example ito nga, no? So itong parehas, may battery yan. Pero, yung process nila ng pag-ubos ng battery, iba-iba. Okay? So on this process, yung battery, pwede maubos yan when heat is produced, no? By the coil, no? So, di ba yung battery kapag pinagdugtong mo yung dalawang ends niya ng yung dalawang ends niya ng wire, umiinit yung wire, no? Ibig sabihin, you can consume all the contents of this battery by just releasing them as heat, no? Pwede mo ubusin yung internal energy nito by releasing heat, no? Okay? So, let me graph that, no? Kunwari, ito yung total energy ng internal energy ng system. O, yung nasa right side, ito B, ito yung A. Pwede ko ubusin yung 100% ng energy na yan in the form of heat, no? Pwedeng heat lahat. Okay? Ibig sabihin nun, basta i-connect ko lang yan, tapos antayin ko na lang maubos to. Okay? So, yan. So, ganun gagawin ko. Ubusin ko yung laman nito. Ubusin ko yung internal energy niya in the form of heat. Pwede naman na ganito, yung ginawa dito sa letter A. Ubusin ko yung laman ng battery na yan in the form of heat and work. Okay? So, pwedeng in two ways. Pwedeng may heat, pwedeng may work. Okay? So, an example niyan. Ano example nito? 'Di ba kapag umiikot yan, umiinit yung makina sa likod, no? Okay. So, yung pag-init ng makina sa likod, nakakaubos yun ng laman ng battery din. At the same time, yung pag-ikot ng LC na yan, yung work na yan, nakakaubos din yan ng laman ng battery. Okay? So, basically, I can measure kung gaano karaming content ng isang battery by consuming all of them. Okay? Yun yung ginagawa ng manufacturer kung paano nila na-measure yung dami ng energy sa isang material. Okay? They will do certain processes, no, to measure the energy stored in these particles, no, in these batteries. No? Okay? So, pwedeng ubusin mo yan in form of heat, and kung ano man yung heat na ma-solve mo, yun yung internal energy niya. Pwede rin naman gawin mo ganito. Okay? So, yung battery, ubusin mo yung laman niya by using this fan, no? So, i-measure mo yung heat, gano'ng kainit yung lumabas doon sa likod. So, yung work, pwede i-solve mo yung number of oscillations of the LSE. Gamit ka ng physics formula. Then i-multiply mo kung ilang beses yan umikot, no? Pwede yon. Mas madali yun kaysa i-solve mo lahat to, no? Okay? So, ganun yung way to measure internal energy. Mapansin mo, we can measure internal energy by determining the work, yung galaw, na kaya ma-produce because of the battery, and yung heat na kaya niya i-produce, na. Ano gagawin mo to measure heat, na? Kuha ka thermometer, tas yun, pwede mo ma-measure yung heat doon, na. Okay? So, yan. Ano pa example na ito? Another example would be yung pagkain. Okay. Kunwari, ito, rebisco. Okay. Paano mo malalaman internal energy ng rebisco? May advertisements na pala ako sa YouTube na. Sana may advertisement din tayo nito. Rebisco. Anyway, so ayan. Kunwari, you have rebisco. Paano mo malalaman internal energy na itong pagkain na to? Ang ginagawa ng mga nasa food industry, no, is ganito, sinusunog nila 'yan. Susunugin nila yung food. Ibig sabihin, malalaman nila yung internal energy by determining the heat, no. Malalaman nila yung energy na to by by burning this, no. Literal na burning. Susunugin mo talaga to. Okay? So, yun yung heat, no, internal energy niya. Okay? Kaya mapapansin niyo yung mga pagkain natin, nakalagay sa likod, kilocalories, no? Ganito yung calories niyan. Kunwari, itong food na to, 500 calories. Paano nila nalaman yun? Okay. Nalaman nila yon kapag sinunog nila yung pagkain. Susunugin nila yon literally na susunugin. Okay? And when all the molecules of this are converted into gases, mako-compute mo yung heat, no? Kasi umiinit yun eh. Okay. So, ibig sabihin, one way for me to measure the energy in this pencil is sunugin ko to. Okay. Okay. Pag nalaman ko yung heat na produce nito, that is the internal energy as well. Okay. So, ibig sabihin, nakagawa na tayo ng way to measure internal energy. So, hindi na siya ito. Although ito talaga yung formula dyan, pero we made another way to measure internal energy. Either you use it as heat o kaya combination of the two. Okay? So that's why we write here delta U is equal to work plus Q. Ito yung tanong ngayon. How do we measure work and Q? Okay? How do you measure that? No? Mas madali to, yes. Pero paano? Okay. Punta tayo sa work. Wala pa pala. Okay, so anyway, mamaya, yung work di-discuss natin. Okay. So anyway, again, yung internal energy ng mga substances sa paligid natin, ng mga bagay-bagay, pwede mo ma-compute yon without even using this, no? Kahit di mo na gamitin yung 1/2 mb square, tas ito, ah, mgh. Kahit di mo na gamitin yung mga formula na yon, no? Ang kailangan mo na lang gawin is ubusin yung laman niya. Okay? Either kainin mo yung pagkain, maglalabas yun ng heat, o kaya sunugin mo yung pagkain, maglalabas yun ng heat. Then you can solve for internal energy. O kaya, gamitin mo siya. Okay? Gamitin mo siya. Okay, for example, ito, yung laman na ito, edi ubusin mo in the form of heat. No? And yung heat, measurable yan eh. Kaya itong example dito, yung laman ng battery, ubusin mo as heat and work. No? So yung work, yun yung ikot ng LC. Control, bilangin mo kung ilan ikot ng LC na yan. Kaya yan, no? Kaya computein yung work dyan. And yung heat, measure mo na lang yung init sa likod. No? Okay? Sabi sabihin, we have new way now to measure internal energy. We don't have to use this formula. Rather, we can use this tool na lang. So, punta naman tayo sa sign convention bago tayo mag-proceed with the work. No? Okay. So, punta tayo sa sign convention for heat and work. No? So, sabi natin, heat and work are positive when the transfer happens from the surrounding to the system. Okay? So kapag yung ating surrounding naggawa ng heat and nagbigay ng heat and work sa system natin, positive 'yon. Lahat ng papasok sa system ay positive. Okay? Ano example nito? O yung system, initin mo, lagay mo sa kalan. Ay, lagay mo sa apoy, no? Nilagay sa loob ng kalan eh, no? Oh, yan. Lagay mo siya sa apoy. Ang mangyayari, yung init ng apoy, matatransfer to the system. That heat transfer is positive in value. Anything na papasok sa system, okay, from surrounding to the system ay positive. Imagine this as your wallet, no? O yung wallet ko. Pag naglagay ako ng pera doon, magiging positive yung value nito. Ganun yung system. Lahat ng ibigay mo sa kanya, positive yung magiging resulta. Ayan, wallet. Lagyan ko ng 5 piso. Ayan, plus 5 yung system. And anything na palabas sa system ay negative, no? Okay. Kunwari, yung system naglabas ng heat, no? Yung kape, naglabas siya ng heat. Negative yung heat doon, no? Okay? So, negative yung Q na value na yun. Pag yung system yung naglalabas ng init. Okay? So, negative yun. Okay? So, yan. Example, yung wallet ko, kumuha ko ng 500. Negative yung balance ko. No? Magne-negative yun. Minus 500. So, ganun din dito sa thermodynamics. No? Anything na binibigay mo sa system is positive and anything na kinukuha mo sa system ay negative. No? Okay? This should be delta U. Hindi ko napalitan, sorry. Okay. So, delta E is delta U. Yung E kasi, ito ginagamit namin kapag Gen Chem. Ang delta U kapag college ka na. Ganun talaga. Okay. So, the changes of internal energies, the difference of internal energy from the final state and initial state. No? Ibig sabihin nun, delta U equals U final. Delta U is equals to U final minus U initial. Ano meaning niyan? Kasi ganito. Can you measure the internal energy of the system before you measure it with heat? Kaya mo ba i-measure yon before? Kaya mo ba makuha yung final? Kaya mo ba makuha yung initial? Hindi, no? Okay. Ang pwede mo lang makuha is kapag pwede mo makuha yung difference nito. Kaya delta U gamit namin. Okay. Pwede mo makuha is yung difference, not yung individual internal energy. Okay. Kasi kapag i-measure mo yung internal energy initially, kailangan mo gamitin yung formula na to. And at final position, kailangan mo rin gamitin tong formula na to. Okay? So, mahirap gawin yun. Mahirap i-measure yung internal energy before and after. Ang pwede mo lang ma-measure is yung difference. Okay, from the initial to final. And we know we can measure the difference using heat and work. Okay? So, yun yung sabi dito. Hindi mo pwede ma-solve ito. Mahirap masyado. Okay? So, gagawin na lang natin is to measure the change. And we know that in measuring the change of the system, in measuring the change in internal energy, you can just use the formula Q plus work. So, hindi mo masasolve to individually. Rather, ang pwede mo makuha is yung change na lang. And the change in internal energy is this formula. Okay? Pag inubos mo yung internal energy, ito yon. Also, whatever changes in the internal energy of the system has to be transferred to the surrounding. Okay? So, ibig sabihin, yung nasa system, malalabas yan to the surrounding. Okay? So, for example, yung laman ng battery, nasa loob yun ng battery. Then, since ginamit natin yun, nasa labas na siya ng system, nasa labas na siya ng battery. Yung heat, nag-dissipate na siya sa environment. No? Yung work, yun, naging ventilador na siya. Na-fill mo na yung hangin. Yun yung work niya. Okay. So, ibig sabihin nun, yung laman ng yung laman ng aking battery, na-convert ko to to energies outside the system. Okay? So, yun lang yung kwento nito. Yung energy ng system mo, nalabas mo sa surroundings mo in the form of heat and work. No? Okay? So, since yung system maglalabas yan ng energy, we can say delta U, negative yon, delta U surrounding, positive. No? So, ibig sabihin, lahat ng energy na nilalabas ng system mo, mapupunta sa surrounding. Pwede rin naman baliktad. Yung energy na ibibigay ng system, ng surrounding, yun yung makukuha ng system. Kunwari, initin ko yung battery. Ayun. So, positive yun for the system. Negative for the surrounding kasi siya yung nagbigay naman to the system. Okay? So, using this idea, using this equation, ilipat mo lang to sa kabila. We say now that delta U system plus delta U surrounding equals 0. And this is actually the first law of thermodynamics. Ito yung sinasabi natin that in any, let me state the first law of thermodynamics. No? In any processes, matter cannot be created nor destroyed. In other terms, energy cannot be created nor destroyed. Ito yung formula na yun. Dito yun nakuha. Okay? Ano sabi? It is only transferred from one form to the other. Ito yung equation na yun. Ito yung meaning nun. Okay? So, yung energy in processes between system and surrounding, naglilipatan lang sila. Minsan andito, minsan andon, no? Pero pag pinag-add mo yun lahat, equal yun sa zero. Okay? Yun yung conservation of energy. Pag ang energy, ang sum ng lahat ng energy ay equal to zero. Conserved ang energy pag ganun. Okay? So ito yung sinasabi na energy cannot be created nor destroyed. Rather, they are just converted from one form to the other. Ibig sabihin, yung energy ng system na convert lang to surroundings and vice versa. Pero pag pinag-add mo yon, the total energy is zero. Okay? So, ganun. Kunwari, ito, yung pencil ko ulit. May potential energy to. Ayan. Na-convert siya to kinetic energy. Kung gaano karami yung potential energy ko, ganun karami yung kinetic energy ko rin, no? So, parang ganito lang yun, no? Ayan. Kung gaano karaming internal energy ng system, ganun din yung dami ng kaya niya ilabas, no? Okay? So, pag pinag-add mo yon, yung quantities na yon, that should be equal to zero. Okay? Yun yung first law of thermodynamics, no? Okay? So, yun lang yung idea. Yung energy ng system, na-convert lang to energy ng surrounding and vice versa. Okay. So, pag pinag-add mo yun, zero yan. Energy, again, energy cannot be created nor destroyed. No? It is only converted from one form to the other. Yun yung equation na to. Doon nila binase yun. Di ba? Ang weird, no? Parang ginawa lang nila tong mga assumption na to. Tapos may law na agad sila. No? Ang galing, no? Yun yung nagagawa kapag walang internet eh. Nakakapag-isip ka talaga, no? Okay, so yun. Na-imagine yung mga tao dati wala silang internet, no? Pero naisip nila yung mga ganitong idea. So amazing. Okay, so yan. So yun lang. Yun yung mga ginawa nila to create the thermodynamics, no? The field of science na nag-study ng energy flow. Okay? So yan. Practice tayo sa pag-solve ng delta U. Okay. So let's have this practice lang. Wala muna tayong recitation for this day, no? Onti lang kasi examples ko eh. Okay, calculate the change in internal energy for a process in which the system absorbs 150 joule of heat from the surrounding and thus 95 joule of work on the surroundings. No? So, ano meaning yan? Delta U is equals to Q plus W. No? Basahin natin ano nangyari sa system. Sabi sa problem, yung system nag-absorb ng heat from the surrounding. Yung heat ay letter Q. Okay? So, 150 joule yan. Since absorption to ng energy from surrounding to the system, positive yon. Kasi sabi ko nga, lahat ng nasa labas, papasok sa system ay positive. No? Positive yung quantity nun. Ngayon naman, kunwari, yung system does 95 joule of work on the surrounding. Ibig sabihin, gumawa siya ng work sa paligid. No? Either tinulak niya yung paligid niya. Yan, naglabas siya ng work. No? So, ano yun? Negative 95 joule. No? If your system does work on the surroundings, negative yun. So, basically, ipag-add lang natin to. No? So, delta U is equals to 150 joule minus 95 joule. So, the internal energy of the system is, ito yung calcu ko. Ayoko i-mental. 150, 95. 55 joules, no? Okay. So, ganyan yung gagawin natin later on to measure the internal energy of the system. Either mag-add tayo ng heat and then kunin natin gano'ng karaming work na gawa niya. Ayun. So, doon mo makuha yung delta U. So, we just solve for this and that. Tapos, pag subtractin lang natin yon, makuha natin yung delta U. So, ganun yung gagawin natin later on. Okay, so again, emphasize ko lang, kapag ang heat ay from surroundings to the system, positive yon. And kapag yung work ay from system to the surroundings, negative yon. Basta papasok ng system, positive. Pagpalabas ng system, negative. How about this one? A system releases 67.5 kilojoules of heat to its surrounding, while the surrounding do 54 kilojoule of work on the system. Calculate delta U and determine whether the process is endothermic or exothermic. Okay. Basahin natin yung sentence na maigi. Releases to the surroundings. Ibig sabihin yan that heat is negative. No? Yung heat ay negative. Okay? Kasi nag-release siya to the surroundings. No? Isipin mo, nagbigay siya ng ganyang energy sa paligid niya. Ibig sabihin, galante siya. Okay? Ngayon, sabi, while the surroundings do 54 kilojoules of work on the system, ang ginawa ng surroundings, let's say, tinulak niya yung system. Literal na tinulak. Yun yung isang idea sa work, tinulak eh. So, yung surroundings naman, ayun, gumawa siya ng work on the system. Okay? So, it did something on the system. So, yung positive yun. Okay? So, yan. So, calculate delta U and determine whether that's endothermic or exothermic. So, basically, pag-add mo lang yan, delta U equals Q plus W, negative 57.5 kilojoules plus 67 pala yun, sorry. Parang 5 eh. Ayusin ko nga. 67.5, 54 kilojoules. 54, 67.5. So, the internal energy change is 13.5 kilojoules. No? Yan. So, that's negative 13.5 kilojoules. So, that's the internal energy change. Ganun lang. Ipag-add mo lang Q plus W. Okay. Just know kung positive yan or negative, ha? Okay. So, malalaman mo naman kung positive o negative depending on saan galing yung energy or sino yung gumawa ng energy. Okay. So, take note of this, no? Important to. Ayan. Pag galing sa labas yung energy, papasok sa system, positive yon. Pag yung system yung gumawa ng, ng energy transfer, negative yon. Okay. From system to surrounding, negative. No? Ganun lang. Now, ito yung problem. Next is determine whether that's endothermic or exothermic. No. Ganito. If your internal energy change is positive, that's endothermic. If that is negative, that is exothermic. Now, when we say endo, ibig sabihin, you are supplying energy. And when you are supplying energy, what's the sign? No? Positive. Okay. Pag nagdadagdag ka ng energy sa system, positive yun dapat. Okay. So, yun yung meaning nun. No? Pag endothermic, positive. Pag exo, negative. No? Kasi your system is releasing energy to the surroundings. Kaya negative yan. Okay. The net energy is negative. No? Naglabas siya ng energy sa paligid. No? So, ayan. So, yan. So, delta U, positive yan kapag endothermic, negative pag exothermic. Meaning ng endo, nag-provide ka ng energy sa system. Eh, di ba remember, basta nagpo-provide ka ng energy sa system, positive yan. Yung ano naman, negative, exothermic yon. Ibig sabihin, yung system nagbigay ng sobrang energy. Sobra yung energy na binigay niya. For example, ito, mas sobra to, di ba? Kaya negative yun. Okay? So, since this is negative, we will say that this is exothermic process. Okay? So, naglabas siya ng heat. Sir, meron bang reactions na delta U is positive? Meron. For example, yung tubig, haluin mo ng asin, positive yung delta U nun. Mafe-feel mo yon, lumalamig yung baso pag nilalagyan mo ng asin. Okay? And the delta U there is 4 kilojoules per mole. Okay? Ay, ako nafe-feel ko yun, medyo sensitive kamay ko eh. Maghugas ka ba naman ng plato every night, no? So, lahat na ata madadama mo sa kamay mo pag naghuhugas ka everyday. Ayan. Pag naggagawa ako ng pang-gargle, kunwari naubos yung aking Listerine dito sa bahay, gagawin ko yung baso, lalagyan ko asin. Mafe-feel ko, lumalamig yung baso. Hindi multo yon, delta U yun. Okay. So, yung system mo, kumukuha siya ng energy sa'yo. Nag-absorb siya ng energy, kaya malamig sa feeling mo. Okay. So, positive yung delta U na yun. Okay. Try nyo yun. Kunwari, mag-gargle kayo. Ayan. Gawa kayo nun. Okay. So, now, ngayon, for now, kasi given yung Q natin pati W, di ba? Given sila eh. What if ipasolve sila? Ayun yung problema natin. Yun yung, nako po, pasensya na. God bless. Kasi, given lang dito, ang dali lang mag-solve, di ba? Pero what if yun yung hinahanap? Okay. What if sila yung hinahanap natin, yung Q pati W? Paano ko gagawin yun, sir? Madali lang. Okay? Paano? Okay, so define muna natin when we say heat. Heat is the transfer of thermal energy, no? So heat is the transfer of thermal energy between two bodies that are different in temperature. So basically, you just determine the difference in the temperature, then you can solve for heat, no? Etong heat, sa calorimetry natin yan i-discuss. How to solve for Q. May formula niyan, MC delta T. Pero saka na yan. Sa calorimetry na natin siya i-discuss na. Focus muna tayo kay work. Kasi ito yung, ito yung basic pa lang compared sa heat na. Okay. So let's focus on the work. Work is the transfer of energy due to existence of unbalanced forces between system and the surroundings. Ibig sabihin, kapag hindi pantay yung forces ng ating system, doon nagkaka-work na. Okay? In physics, we define work as W equals Fx na. Okay? Pero sa chemistry, ang gagawin natin, we assume that the system does the work. So, gagawin natin negative F delta X yan. Okay? So, this is the actual equation. Pero, since we assume that the system does the work, ito yung gagamitin natin. W equals negative F dx. Okay? Ayan. Okay. So, yan. So, we assume that the system does the work. So, negative F dx. Okay. Medyo important kasi talaga yung negative sign sa atin. Okay? Okay. So, now, one way to illustrate work is by expansion or compression of a gas in a piston. So, ito talaga yung ginagamit, no, to determine the work, no, of the gas. No. Kaya nga mapapansin nyo sa prob set nyo nung nakaraan, may pinapahanap na pressure of the gauge, no? Kasi yung pressure of the gauge, you can use that to determine work, okay? So, assume we have a gas in this, no? We have a gas here. May gas dyan. So, ayan. So, W equals negative F dx or delta x. Delta x. Okay. So, if our gas expands, no? Gas expands, ano mangyayari? If the gas expands, ito yung initial mo. Tapos yung final, andito na. Itutulak niya yung takip, no? So, syempre, may change yon in x, no? May change yun sa distance. Okay? So, yun. Let us try to derive work from this, from this diagram. Okay? So, the force of the gas is, ano yung equation for the force of the gas? The force of the gas is equal to the area times the pressure. Okay? So the force of the gas is equal to the area, the surface area of the cylinder times the pressure. Okay? So yung pressure ng gas times mo yung circle na to, yung area ng circle na yan. That's the force. No? Okay? So since mahirap i-measure yung since medyo mahirap measure yung force, no? Mas madali ma-measure yung pressure ng gas. Bakit? Kasi in measuring the pressure of the gas, kailangan mo lang gawin is maglagay ka ng pressure gauge, no? Maglagay ka lang dyan ng gauge. Okay? So yan. So we can rewrite this as P equals F over A. Okay? So yan. So the pressure is force over area, yun yung nasa prob set natin. Pero if you rewrite that, you can get this now. The force is area times the pressure. Okay? So mahirap kasi i-measure itong force, ang madali i-measure ay yung pressure. No? Lagay ka lang ng gauge dyan. Mapansin mo naman, aakit yung gauge, tapos itutulak niya ito. No? Okay. So madali ito i-measure. Itong area, constant naman to eh. Kunwari, itong piston na to, 5 mm to. You can compute for the area, pi r square yan. Okay? So let us use this, no? So instead of using F, ito ipasok natin dito. Yan. Let us plug this equation into that, no? Okay. F delta x. So again, we know that force equals area times the pressure. So plug in natin yon, negative P A delta x. Now, what is the area? The area is ito, yung area ng circle na to. Ayan. Delta x is the difference in the volume. Now, the question is, what is area times delta x? What is this? That is the volume change, no? That is the volume change, no? Kasi remember, area times height equals volume. Okay, so ibig sabihin, itong part na to, itong delta x times the area is the volume change, the changes in the volume of the gas. Okay? So ibig sabihin, we know, okay, that A times delta x is equal to the changes in the volume of the gas. No? So, continue tayo. P is equal to, W is equal to negative P delta V. Okay? Ito na yung bagong equation natin. Mas madali ito gamitin. Okay? So, gagawin mo na lang, measure mo yung pressure ng gas, dugtungan mo yan ng pressure gauge, tapos alamin mo ano yung height difference or yung volume change. No? Yan. Then you can get the key W na. Okay? So, plug in mo lang yung mga na-solve mo. Makukuha mo na yung W. Tapos yung W na yon ipa-plug in mo dito sa delta U. Okay? So, ganun lang gagawin natin. No? So, this is the derivation of W. So, according to physics, W equals negative F dx. We know that force is equals to area times the pressure. So, we plug it here. Area times the change in the height is equal to the volume. So, this is delta V. If ito ay small steps, no? That is dW equals negative P dV. Okay. Kapag bahagya-bahagya lang, in a proportional, kapag dahan-dahan yung pag-increase ng volume, yan. So, we use this formula, dW equals P dV. Okay. Important to mamaya, no? Ito yung calculus form niyan. Calculus form. Okay. Magka-calculus tayo mamaya, ha? Okay. So, the general equation for work is negative PdV o kaya negative P delta V. Okay. So, kapag calculus yung changes ay D. Sinusulat as letter D. Kaya mapapansin nyo sa calc nyo, may dx, dy. Yung D na yon change yon in x or change in y. Okay, pero small yung changes na yun, infinitesimal. Okay, so what if the gas contracts naman? Okay, if the gas contracts, if the gas contracts, ano mangyayari? Maburahin ko lang to. Let's talk about the contraction of the gas. Nawala yung pang-erase. Ayan. So, let's talk about the contraction of the gas. Ibig sabihin, mas maliit yung final volume. So, ito yung initial. Ito yung final. Okay? So, ang mangyayari sa atin is yung delta x natin ay magiging negative na. Okay? Bakit siya magiging negative? Kasi paatras siya eh. Pababa yung value niya eh. So, ibig sabihin, mas maliit yung final kaysa sa initial. So, negative yung delta x. So, we will have f delta x na lang. Okay? So, mawawala yung negative sign. Okay? So, W equals, yung f, palitan natin A, P, delta X, and W is P delta B. Or dW equals P dV. So mapansin nyo, kapag work, no, gas contraction, the work is positive. Pag gas expansion, the work is negative. No? Ano ba nangyayari when the gas contracts? Ganito. Tinutulak kasi siya ng surroundings. No? The pressure of the surroundings or the external pressure pushes this. No? Tinutulak niya ito. Okay. Kaya nagko-contract yung gas natin. Ayun lang. So, nagko-contract siya kapag pinupush siya ng environment ng paligid. Kaya lumiliit yung volume niya. Okay? Pero kapag gas expansion naman, yung pressure ng gas yung tutulak doon. Until maging pantay sila. Until they are equal. Okay? So, ayun lang. Focus pa tayo dito. No? So, more on isothermal expansion and compression of forces process. When we say isothermal, same temperature lang yung focus natin. Marami kasing uri pa nito pero yung basic lang aalamin natin today. And so let's talk about the isothermal expansion and compression processes. Irreversible expansion, ibig sabihin sudden increase in volume. Kunwari, ito yung pressure 1, volume 1, tapos ito yung pressure 2, volume 2. Okay? Let me use other colors. Kulay blue na pala yan. Burahin ko lang ha. Ito lang. Kunwari, ito yung pressure 1, volume 1, expansion to. Okay? So we started with the high pressure and then low volume. And then we will end up with this one, P2 and V2. Kapag sinabing sudden increase, no? Biglaan yung increase, no? Okay. So biglaan, tinulak mo bigla, no? Okay. So pag tinulak mo yung bigla, ang gagamitin nating equation ay ito, yung area nito. Okay. So ganun yung sabi sa sa P6, no? Kapag sudden increase, yung area from this to that is, yun yung equation. Yun yung work na ginamit mo. So, only this portion. Kasi biglaan eh. Pag biglaan, square yung ganap, no? Okay, square siya. Okay, so naka-square yun always. So, to solve for W, so that is negative P, that is negative P lang, delta B. So, P delta V lang yung gagamitin mo dyan. Okay? But yung P na gagamitin is yung final pressure. Negative P final or the P2. Or let's say P external na lang. P external delta V. So, always ang final pressure ay P external. No? Kasi sabi nga natin, equal na yung pressure nila. Okay? So, at final stage, pag huminto na yan, equal na ito and ito. Okay. So, ito na lang gamitin natin, P external, delta P. So, that's W equals negative P external, final volume minus initial volume. Kapag irreversible, sudden increase, no? So, we are just obtaining this portion. Okay? How about this one? How about itong part na to? Dito tayo. Reversible expansion. Pag sinabi namang reversible, dahan-dahan. Ito kasi binigla mo, no? Kasi kaya hindi na siya nakapag-adjust. Sabi niya, uy, andito na ako agad. So, ito na lang kukunin mong area. Okay. Nagugulat yung gas natin. Kaya, ito na lang yung area na kukunin mo. Biglaan eh. Okay. So, kaya itong portion lang. And this portion is, P2 delta B. Okay. Yung area niyan is P2 delta B. Okay. How about if dahan-dahan? So kapag dahan-dahan, lahat yan dadaanan mo. Lahat ito dadaanan mo. So you are actually getting the area under the curve, no? So magka-calculus tayo. So yung individual points na yan, dadaanan mo yan lahat, no? Again, kapag pag irreversible, biglaan kasi, no? Magugulat na lang siya, andun na siya. So yung area is ito na lang, itong portion lang sa ilalim. Okay? Pero kapag sinabing reversible, ibig sabihin dahan-dahan yung increase. So ibig sabihin niya, madadaanan niya to lahat, no? So you are actually getting the area under the curve, no? So the equation to be used is dw equals negative p dv. Okay, so integrate natin yan. Marunong na ba kayo integral? Don't worry kung di pa marunong, okay lang. Kasi bibigay ko naman yung equation eh. So kapag infinitesimal changes, gagamitin mo yan ng calculus, no? Okay, calculus yan. dw equals negative p delta v. Okay? So this is from initial to final. Now, ano yung gas natin? Assuming that the gas is ideal, ano meaning kapag ideal gas yan? We follow PV equals nRT. So if we want to get the pressure, that is nRT over V. Okay? So we plug that here. So the integral of dW is just W. O yung negative sign, ilalabas ko. Initial, final. So yung pressure natin, mapapalitan na siya. That will become nRT over V dV. Yung N, yung R, yung T, constant yan. Okay, constant yung mole, constant yung gas constant. Obviously, constant nga pangalan niya. And yung temperature are constant kasi we are assuming isothermal expansion. So itong nRT, constant yan. Pwede mo yan ilabas, sabi ng calculus. Negative nRT, initial, final, dV over V. Anong integral ng 1 over V dV? No? Sabi sa calculus, 1 over x dx is equal to ln of x. Okay? So, ibig sabihin, this one is W equals nRT ln of V. But I have to evaluate it from final to initial. Okay? So, final to initial, ibig sabihin, that can be written as negative nRT ln VF minus VI. ln VI, sorry. ln VF minus ln VI. And itong LNVF minus LNVI, pwede ko yung pagsamahin using the properties of logarithm. I will get this, no? nRT ln VF over VI. Dami nangyari, no? Ayan na yan. Pag marunong ka mag-calculus, madali lang yan. Okay. So, ayan. So, mapapansin nyo, magkaiba yung equation natin, no? Kapag irreversible, you're just getting the square, no? Itong square lang na to. So, that's P delta V lang. Whatever this P is, then yung change sa B. Square lang kasi siya. Pero, if we are on a reversible process, no? Pag reversible expansion tayo, we are getting all the area under the curve, no? Kasi dinadaanan natin lahat yan eh. Pag irreversible, biglaan, nagulat na lang siya, andito na siya, no? Hindi na siya nakapag-adjust. Pero kapag reversible, we are getting all of this, no? Ayan, lahat ng iyan. So we have to use calculus, no? Kasi infinitesimal yung change, no? Dahan-dahan yung change. So calculus yung gagamitin mo diyan. So the equation is dW equals negative P delta dV. And we assume that the gas is ideal, so we plug in PV nRT, or P equals nRT over V. Yung R, yung N, yung R, yung T, constant yan, so ilalabas mo yan. So the integral of this, according to calculus, is ln x, or in our case, ln V, kasi V yung ating variable. evaluating it from from initial to final, we will get this and negative nRT ln Vf over Vi. Ayun. Baka mamaya umiiyak na kayo dyan. Okay, umiyak. Ano pa lang yan? Basic pa lang yan. Tsaka binigay ko na naman yung equation. Ibig sabihin din ako magpapaderive. Pero it will still be better if you can um it will still be better if you can do calculus, no? Kasi but if sa prob set magbigay ako sa inyo ng ibang form ng gas equation. Madami kasing gas equation. We have the ideal gas, we have the real gas equation, we have the Berthelot equation, so on and so forth. So ibig sabihin iba-iba yung equation for the P, no? Dahil nagkaroon ako ng idea, siguro magbibigay ako ng ganun, no? As group activity naman. Okay. Pero for now, let's assume that this is ideal. So yan. Sana marunong na mag-calculus, no? I think nakapag-calculus na kayo last sem. Pero kung hindi, edi okay lang. Kabisaduhin nyo na lang to. Now, let's talk about compression. So, compression, baliktad naman. Ito yung final mo. Okay, let me use red ink. So, this is your this is your initial. This is your final. This is your delta V. Okay. So, mangyayari, kapag irreversible compression, magugulat na lang yung system. Sudden decrease, no? So, from here, gugulat na lang siya, uy, andito na ako. Okay. So, bale, ang kukunin mong area dyan is ganito. Katulad ng ginawa natin, so, since sa P2 tayo nag-end, so, ito yung magiging final height natin. Then, multiply mo yun sa delta B. Okay. So, all of this area below here ay yung work natin. So, that's negative, P delta B. P external delta B. Take note that the work is positive kasi nga yung surroundings gumawa ng compression. Okay. So, naging positive na yung W natin dito. Take note that the P2 is the P external kasi we assume that at final pressure, at the final state, yung pressure ng outside and the inside ay equal na. Okay? So, ito yung equation, Vf minus Vi, P external, positive. Ayun lang, ganun lang. Yung square lang. So, ito yung height. Kasi dito tayo natapos. So, ito yung height. Tapos, ito yung length. No? So, length times, ito yung height, ito yung width. No? So, ayan. And so, ayan, basta yan. Length times width, ayan. You get the area. Kung saan ka natapos, dun yung vertical axis mo. At ba kanina dito tayo natapos. Kaya dito yung vertical axis. Yung area in between them, yun yung work. Tapos dito naman, dito tayo natapos. So, ito yung vertical axis mo. Ito yung x-axis. So, whatever the area covered by that is your work. Yan. Dito kasi tayo natapos. Kaya ito yung area na. Ayan yung work. Now, let's talk about reversible. Pag sinabing reversible, dahan-dahan uli. Dahan-dahan lang yan. P1, B1. So, kapag dahan-dahan, etong points na to, lahat yan dadaanan mo. Okay. So, ibig sabihin, the area that you are getting is the area under the curve. No? So, all that area under the curve. Again, kapag sinabing reversible, yung area under the curve yan. Okay, so, ibig sabihin, calculus tayo ulit. dW equals PdV. This time, positive na yan kasi compression. So initial, final, assuming that gas is ideal, we say P equals nRT over V. Assume ideal gas behavior. So this will become nRT over V, dV, initial, final. Yung nRT, labas mo kasi constant sila. Integrate Fi, 1 over V, dV. So same lang yan sa kanina. ln Vf over Vi. This time positive nga lang. Okay? So those are the equations. Okay? So for irreversible expansion, negative P external Vf minus Bi, negative P delta V, final minus initial. Pag reversible expansion, negative nRT ln Vf over Vi, bakit naging ganon? Kasi we are getting the area under the curve, no? So, ibig sabihin, you have to integrate the area under the curve, no? Okay, so this is that, no? Integrate. Plug in mo yung ideal gas equation, yan. Labas mo yung nRT kasi constant sila. So, you are left with 1 over V dV. And according to calculus, if you have that form, ln x yan, evaluate it from initial to final, you will get this. No? I will not go through the details of calculus na kasi although nagtuturo ako ng calculus sa review lang yung tinuturo kong calculus sa mga sa mga chem. Pero ayun. Basic cal lang naman yan, so kailangan alam nyo na. Okay. So, kapag irreversible compression naman, so ito yung sudden compression. So, you started here, nagulat na lang siya, andito na siya. So, the area under this curve, no, is just the square, no? And that's P2 P2 times the delta B, or the P external delta B. Take note that the W is positive here, no? Kasi kapag compression, positive yung work sa system. Positive yung work sa system. And kapag compression, ayan, reversible, you are also getting the area under the curve. So ayan. So dahan-dahan lang. Same pa rin, nawala lang yung negative sign. Okay? So ayan. Ito question. Between reversible and irreversible expansion, sino mas malaki yung work? Reversible or irreversible? Sino mas malaki work dito? Look at the diagram, yung shinade ko. That should give you an idea kung sino mas malaki yung value. Reversible, irreversible, sino mas malaki yung work?
Reversible.
Reversible. Malaki yung area ng reversible. Sakop yun eh. Sa irreversible kasi ito lang. But for reversible, added itong portion na to. Okay. So we can say that the maximum work for expansion is the reversible work. No? Maximum work. Okay, kapag expansion. Maximum expansion work ang reversible. Ito yung minimum expansion work. So, yung irreversible. Kasi mas maliit yung area niya. Okay. So, ibig sabihin, mas malaki yung value nito. Mas malaki value nito kaysa dito. Patunayan natin yun mamaya sa problems. Okay. Ito naman, between irreversible and reversible, sino mas malaki value? Pag compression. Look at the area. That should give you an idea kung sino mas malaki.
May kasi pa ako.
Yung irreversible. Yung irreversible mas malaki, obvious. Kasi yung reversible, ang kinuha niya lang itong nasa ilalim. Pero yung pag irreversible, lahat yan, damay itong nasa labas ng curve. No? So this is the maximum compression, compressive work. No? So ang irreversible processes, ang maximum compressive work. Pag reversible naman, ito yung minimum compressive, no? Minimum, basta yan, minimum yung reversible. Okay, so that should give us an idea kung sino mas malaki, sino mas maliit, no? Yung value. Let's have this example. 10 moles of hydrogen gas expand isothermally from 10 to 65 liters against a constant pressure of 2 atm. At 25 degrees Celsius, calculate the work done by the gas reversibly and irreversibly. No? So this is expansion. We have reversible and irreversible expansion. Okay. O, ang tanong, sino kaya dapat mas malaki value niyan? Expansion. O, remember, kapag expansion, yung ating graph ay ganito. Ito yung ito yung irreversible. Ang daming R. Ito yung reversible. Kailangan, ang mas malaki yung value natin ay for the reversible. Okay, so patunayan natin na tama yung idea natin kanina na mas malaki yung value nito kaysa dito. Kasi for expansion, mas malaki yung area under the curve kapag reversible kaysa sa irreversible. Let's try that na. So given, moles of gas is 10 mole. Temperature is 25 degrees Celsius or 298.15 Kelvin. Volume, VI, VF. Okay. Okay, so 10 liters to 65 liters. And then pressure. Ang binibigay na pressure mostly is the final pressure. Okay. P external. Constant pressure, 2 atm. Now, calculate natin A reversibly. Okay, so we know the formula for work kapag reversible ay negative nRT ln VF over VI. Plug in na lang. 10 mole. O yung R na gagamitin dito is the gas constant na naka-joule. 8314 joule per mole Kelvin. Take note of that. Ito yung gagamitin natin kasi energy tayo eh. Ito ay galing dun sa 0.08206 liter per mole Kelvin. Dun lang din to galing. Kinonvert lang to joule. Na tamang convert lang. So, yan yung gagamitin natin. 8314. Oopsie. Nagulo sulat. 8314 joule per mole Kelvin. Temperature 298.15 Kelvin. ln final 65 over 10 liters. Okay. So the units of liter will cancel out. Yung mole magka-cancel out. Yung Kelvin magka-cancel out. So the final unit is joule, which is an energy unit. Pindot natin sa calcu, 10 times 8314, 298.15 ln 65 over 10. Okay. So the energy is kilojoules ko na ha. Negative 46.40 kilojoules. Okay. So that's the work if that is reversible. Okay. So negative 46.40 kilojoules. How about irreversible? Irreversible. So sabi natin kapag irreversible, yun yung square lang. So naka-square lang yan. So negative P external delta V. Or this is negative P external VF minus VI. So what's P external? That's 2 atm times Teka lang, kulang ako ng space. Kulang ako ng space. Pero tama yun ha. Kulang lang ako ng space. Burahin ko na lang to. Ayan. So, irreversible tayo. Okay. So, W equals negative P external Vf minus Vi. No? Delta B. Sabi natin, yung final pressure ay 2 atm. Final volume is ang final volume ay nabura ko kasi yung given, hindi ko tuloy makita agad. So 65 liters minus 10 liters. So the work here is negative times 65 minus 10. Negative 110 liter ATM. Okay. Tanong, yan na ba yun? Hindi. Okay. Yung liter ATM, this can be converted to joule. Okay. Remember, yung gas constant natin ay 0.08206 LATM per mole Kelvin. And also, that is also 8314 joule per mole Kelvin. So, gagawin natin, divide natin yung R dito. Okay. So, i-divide natin yung R dito. Yung R na energy and yung R na LATM. Okay? So, ito yung R na energy ito yung R energy. Okay? Divide mo yun sa R na LATM. Liter atmosphere, yung numerator. Okay? So, ganun gagawin natin. Negative 110 LATM. Okay? So, 8314 joule, mole, Kelvin. 0.08206 LATM, mole, Kelvin. Papansin mo yung mole Kelvin, pwede mo sila makancel. Yun. So, 8314 joule divided by 0.08206 liter atmosphere na lang natira. Yung mole Kelvin, parehas yun magka-cancel. O yung LATM, pwede mo i-cancel doon. Okay. So, you are left now with the joule. Joule na lang yung natira. Again, ang basa dyan ay joule, hindi siya joule. Okay. So, plugging that in the calculator, we will get negative 11.14 kilojoules. This is ito yung reversible. Ito yung irreversible. Is it same as sa logic natin kanina? Yes, no? Kasi sabi natin sa logic kanina, based on the graph, no? Sabi natin doon that mas malaki yung reversible kaysa sa irreversible, no? Kasi looking at the graph, no, mas malaki yung area under the curve than the square sa ilalim kapag expansion process. So, kailangan nyo makuha nyo consistent doon sa mga pinagsasabi natin dito kanina. Minimum expansion work kapag irreversible, maximum expansion work kapag reversible. Ayun nga yung nakuha natin. Maximum expansion work kapag reversible, minimum kapag irreversible. Okay. Ayun lang. Next. Ito expansion na naman. Okay. Pag compression, ganun pa rin naman, no? Pero wala lang, gusto ko lang masanay na expansion tayo. Okay. Kasi usually sa chemistry, no, sa thermochem, puro expansion process ang dinidiscuss, no? Yun yung usual. Kaya puro expansion example ko dito. Okay, so ito. This is up 4 points. Okay, may points dito. Paano kaya ako kasi wala tayong hindi tayo tulad ng Zoom talaga eh. So siguro paano ka points? Iisip ako. First 10 to answer my 2 points. Pag tama yung dalawa. First 10, ko-comment kayo. So, yung 1 point is for the reversible. Yung isa is for the irreversible. Ang gagawin nyo, ang itatype nyo is, yung pag nag-send kayo, magkasama na yung dalawa, ha? Magkasama na yung A, yung B, no? So, type nyo sa equation nyo, ito, W, equation, tas saan siya equal. Kahit yung equation lang, tas saan siya equal. Tas yung B, W, equation, then saan siya equal. Okay? Okay. So, yung number na lang. Pati yung unit, don't forget the unit. Ha? Pag mali unit, mali. Okay. So, the first 10 na mag-submit, yun yung ko-consider natin. 2 points yan. Okay. So, isa ditong point, isa for the other point. Again, isi-send mo yan ng isang chat lang. Okay. So, the first 10 that will send will get the points kung tama. So, I'll be waiting for your submissions. Okay. So, wait ko yung inyong mga answer. Habang naghihintay, ako ay magbubukas ng delivery ng Shopee. Unboxing ako dito. Wala pa naman nagsasend. Nag-unboxing lang ako. Wala pa rin nagsasagot. Wag na first 10, first 15. Para maraming mas may points. First 15 na mag-send, yun yung i-check natin. First 15, mas marami nang magkaka-points this time. Okay? So, ang aking binili ay cat box ng pusa. Ayan. May libre siyang ring ng pusa. Okay. Walang nakasulat. Nauna mag-send tas walang sagot. Wala pa rin nagsasend. Nagugutom na yung pusa. Kung kakagutom na, kain kayo. Hindi ko naman kayo i-judge. Kasi wala naman kayong camera. Ay, may nag-send na ba? Tignan ko. Yung activity lang pala yan. Wala pa rin nagsasagot. Baka mauna pa ako matapos mag-assemble neto. Anong equation gagamitin? Expansion yan. So basically, just follow the equation I have written earlier. Okay. So same lang din sa ginawa ko kanina. Okay, so until now, wala pa rin. First 15 na magsagot, may 2 points. Pag tama. Malapit ko na matapos ma-assemble to. So, alam nyo na. Solve na. Dali. Two hours na pala. Don't worry, patapos na naman tayo. Okay, magbibigay na ako ng time limit. Ayan, may nag-comment na. Ayan. Don't forget the unit. Okay, so Aldrin, unit. Yung unit, wag kalimutan. Ayan. Diba yan yung lesson natin? Units ay important. Ako patapos na ako dito sa ina-assemble ko. 12:45. I-close na natin yung poll. Okay. Last 3 minutes. Isa na lang ikakabit ko na screw, tapos na ako. Kailangan tapos na rin kayo. Last 2 minutes. Si Aldrin pa rin yung may sagot. Okay, dalawa na. Si Honey, kailangan dalawa yung answer na A and B. Tapos ko na i-assemble yung aking cut box. Okay. Okay. Ayan na, nagsisilabasan na answers. Okay, so it's 12:45. Pag nag-46 yan. Dali, habol. Okay, so stop na tayo sa poll. Next time na lang yung iba uli. So I will only accept answers up to kay Mr. Manyosa. So 1 point for A and B if correct. So hanggang dito lang kay John Gabriel yung ating accepted answers. Okay. So, paano natin sasagutan to? Okay, ganito lang. So A, irreversibly. Okay, so sabi natin kapag irreversible expansion, that is ano? Kapag irreversible expansion, iyan ay ano? W equals P external or the P2 delta V. Diba? P2 delta V yan. Ano problema dito? Ang problema, dalawa yung pressure, sir. Alin dyan gagamitin ko? Okay. Ayun siguro tanong nyo kanina pa, no? Alin dyan gagamitin ko, sir? Dalawa yung pressure eh. May sinabi ka 15 ATM, may sinabi ka 1 ATM. Alin dyan? Okay. Ganito. Okay. So, ang gagamitin mo dito is, ito yung initial, syempre. Ay, ito yung pressure initial. That's the pressure initial. Then, ang final pressure ay ito. Di ba sabi natin, ang P na ginagamit natin is the final pressure, the P external. So, ang gagamitin mo dapat ay 1 atm. Kaya nga sabi ko dun sa graph, di ba? O, balikan natin yung graph. Asan yun? Kasi yun, sinabi ko dun kanina, yung pressure to, yun yung always yung external pressure, no? Yung final pressure. Okay. So, yung P2 ang gagamitin parate. Okay? So, again, P2 ang gagamitin parate. Yan. Yan. Naka-emphasize naman yung P external. Dito, di ko na in-emphasize, no? Basta yun ha, the pressure that will be used ay always dapat ay ang P2. Okay, so yun lang. Kung nakita nyo na ito yung ginamit nyo, yung P1, ibig sabihin mali na. Again, always, I would like to emphasize that the pressure to be used ay always ang final pressure or the external pressure pag sinabi. Okay? So, yan. So, expansion to. So, negative to. Okay. So, that's negative 1 atm times the change in the volume. Okay. Hala, ito na naman. Susunod na tanong. Ano, sir, yung change in volume? Hala, sir, ano yung exchange in volume? Kasi ang meron ako, initial volume. Ano yung final volume ko, sir? Is there a relationship between pressure and volume? There is, diba? And that's the Boyle's law. Remember Boyle's law, P1 B1 equals P2 V2. Ganun. Nakita nyo ba yan? Hindi. Kung hindi, okay lang. No? Okay lang, 1 point lang naman to eh. Pero yun na nga, kapag hindi given yung ibang mga bagay, you can use gas laws. No? Kasi gas to eh. We assume na ideal gas to kanina pa, di ba? Don't forget that, okay? So, kapag initial volume lang binigay, walang binigay na final volume, you can use Boyle's law, okay? So, let's solve for the V2. That's V2 equals P1 V1 over P2. Initial pressure, 15. Initial volume, 4. No? 15 atm, 4 liters. Pressure 2 is 1 atm. So, what's the final volume? 15 times 4 divided by 1. 60 liters. Kita nyo yan? Okay. Ganun ha. Lista ko dito yung mga given. V initial, 4 liters. VF, 60 liters. Boyle's law ginamit dyan. P initial, 15 atm. P2, ito yung gagamitin, 1 atm. Ganun ha. Ayan. Okay lang naman kung hindi nyo na-get siya sa una. Pero yan, nabigay ko na yung mga trick, no? Ganito yung mga usual na nangyayari sa questions. Eh. Okay? Ayan, burahin ko na yan para mas malinis. By using Boyle's law, I got VF as 60 liters. So, final minus initial. 60 minus 4, negative 56 liter ATM. Now, convert mo yan, 8314, 0.08206. Okay, magka-cancel yung LATM. And the answer will be 5,067 or 5.67 kilojoules. May tumama? Wala. Okay. So, yun, no? Okay lang yan. Walang tumama. Basta ganun ang gagawin nyo, no? Hindi tayo limited sa equations lang na binigay natin. We can use the other equations discussed in chemistry such as the Boyle's law. Pwede ka nga gumamit dito ng Charles law, Gay-Lussac law, Avogadro's law. Okay? So, pwede gamitin yung mga yon. And always take note that the pressure to be used is the P2. Okay? So, yan. How about reversibly? Letter B, reversibly. W equals negative nRT ln Vf over Vi tayo dyan. Diba? Now, R is given. 8314 yon. Temperature is 298 Kelvin. 0.15. Sama natin yung 0.15 para di siya malungkot. Yung final initial volume, nakuha na natin. Nag-missing natin yung N, moles of the gas. How will we find for the moles of the gas? We use PV equals nRT. To solve for moles, that is PV over RT. Tanong, anong pressure, anong volume gagamitin ko? Any of those, no? Pwedeng P1, pag P1 gagamitin mo, V1 gamitin mong volume. Pag P2 gagamitin mo, V2 gagamitin mong volume. Okay? Kasi constant yan eh. Yung pressure volume, that's a constant. Okay? That's constant all throughout. No? Ibig sabihin, yung moles din, constant din yan. So, kung yung P1 gagamitin ko, use the V1. Kung P2 gagamitin ko, use the V2. Pero, for consistency, yung initial conditions yung gagamitin natin to identify the moles of the gas. No? So, gagamitin ko na lang is P1, V1. Although, pwede rin gamitin P2, V2. Okay? Kasi, again, P1 and B1, yung product nun ay constant, which is the same as P2, V2. Okay? So, let me solve for the moles. That's 15 ATM. Initial volume, 4 liters. R is 0.08206. LATM, mole Kelvin, and then the temperature is 298.15 Kelvin. Mole is 15 4.08206 times 298.15. 2.45 na lang. Round off. And 2.45. So that's 2.45 mole using the ideal gas equation. Don't forget those. No? Kapag may nakita kayong gas, gamitin ang ideal gas equation. Huwag manghinayang sa equation. Okay, plug in negative 2.45 mole times R, 8314. Temperature, oops, kulang ng space. Adjust ko na lang, kulang ako sa space. Negative 2.45 mole, 8.314 joule mole Kelvin. Temperature to 98.15 Kelvin. ln. Final volume is 60. Initial volume is 4 liters. Pindot-pindot sa calcu, negative 2.45 8314 298.15 ln 60/4. This is negative 16.45 kilojoules. And again, walang tumama. Okay lang yan. No, wala tayong nakakuha points, no? Ayan, sabi ko sa inyo, walang points today, no? Yun yung hint. Na kasi mahirap siya. Pero ganun lang, okay? Just in case na makakita kayo ng problem na parang kulang-kulang, gamit kayo ng gas laws, no? So, you can use Boyle's law, Charles law, Gay-Lussac law, lahat ng law, Avogadro's law, ideal gas equation. You can use all of them to get all the necessary info you need in the equation. Okay? So, ganun lang. Please take note of that. Okay? Ibig sabihin, may mga masasagot na kayo sa mga group assignment natin in the future. Okay? So, ganun lang. Hanapin nyo muna lahat before you plug in everything. And always, the P2 ang ginagamit dito. Especially kapag irreversible. P2 ang ginagamit parate. Okay? P2 ang ginagamit parate. This one is open for points. First 5 to answer this will get 1 point. Okay. Ang tanong, may makakakuha ba niyan? Ayan lang yung question. Yan lang. Wala nang iba. Okay. None. Ano yung value? Ano yung value ng none? Okay. First 5. Okay. 1, 2, 3, 4. And last one. Okay. Sige. Sige, up to 10 na. Up to 10. Para may mga makaka-points. 1, 2, 3, 4, 5, 6. Copyhin nyo na yung message ng iba. Diba? Nag-send doon sila agad. Ilan na to? Wait lang. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, hanggang kay Giselle lang. Sorry. Hanggang kay Giselle lang. Okay. Porket 0 na message ng iba, message na rin yung iba na 0. Okay. Ito tanong, bakit? Anyone, sa mga nagsagot ng 0, bakit kaya? Kasi walang given, ganun, kaya 0. Habang nire-record ko yung points nyo, bakit 0 sagot nyo? Kasi sabi ni Google. Wala pong need i-overcome na pressure. Very good na. So, wala kasing pressure external. Diba sabi ko sa inyo, yung pressure na gagamitin mo kapag work is the final pressure always, the P2. So, if wala kang P2, again, at the vacuum, there is no pressure. No? Ibig sabihin, wala kang i-resist na force. No? Wala kang i-resist na, na puwersa. So, ibig sabihin nun, 0 talaga yon. Okay? So, pakita natin mamaya. Abuyo, Baisa, Memoriado. Ayan. Siyares. Megano. And si Giselle Bernal. Okay, hanggang dun lang. Pasensya na sa mga hindi nakapag Bernal. Ayan, so 10. Okay, bakit uli? Kasi sabi nyo, walang external force. No? Okay. Kapag sinabing vacuum kasi, always, ang final pressure ay 0. So, if gagamitin mo yung PdV, 0 yan, times whatever is this, 0 pa rin yung sagot. Okay? So, there is no work when expanding against the vacuum. Okay? What if mataas yung pressure, tapos walang change in volume? Zero din yung work, no? Example, itulak ko yung pader. May work ba doon? Wala. Walang work doon pag tinulak ko pader. Kasi, pag tinulak ko yung pader, walang displacement. Remember, W equals F delta X. Hanggat walang displacement naman, walang work. So, kahit itulak ko tong pader na to, magsama-sama man tayong lahat, no? Pag hindi gumalaw yung pader, walang work doon. Kahit pagod na pagod tayo. In terms of vacuum naman, kapag wala ka namang force na kakalabanin, no? Walang final force, no? Walang final pressure, ibig sabihin, zero yan, no? Okay? Mag-expand man ng mag-expand yung gas hanggat walang external pressure, I mean external pressure, external force, zero ang work. Okay? So, yan ha. Take note of that. So, these are your group assignments. So, ito yung mga group assignment. I want you to solve for the reversible and irreversible. Ay, hindi. Puro irreversible pala to, sorry. So, itong mga to ay puro irreversible processes. Irreversible. Okay, so lahat ng iyan ay irreversible process. Okay, kasi hindi pa ako madaling araw ko na ito natapos hindi ako makakita ng ibang examples pa. Okay, so for now, puro irreversible yan. So, puro W equals negative PDV or PDV lang yan. No? So, yun lang gagawin mo dyan. Okay, so that will be our session for today. No? So, these are all irreversible. No? Ito. Ayan. Okay, ayun. So, lahat yan ay irreversible. And ito, ano lang to? Alam nyo na yung equation na gagamitin nyo dyan. Basahin nyo lang maigi. Okay? So, ito isasama to sa inyong prob set, no? So, i-add nyo to. Kailan ipapasa yung prob set? Matagal-tagal pa. Okay. So, sa Sabado, wala tayong session kasi holiday, no? So, that's Labor Day. We honor those who are in the working force, especially yung mga hindi pa sumusweldo. So, yan. So, yan. Let us honor them in that day na lang, no? So, hindi lang naman yung mga nagtatrabaho na may sumusweldo. Yung mga tumutulong din sa bayan. Okay? So, tulungan let us honor them on that day. So, sabihin, wala tayong pasok na. Okay? So, by next meeting, we will discuss this. Asynchronous tayo nito. Okay? So, sa asynchronous, magbibigay pa rin ako ng group assignment doon. Don't worry. Para may points kayo. So, ang i-discuss ko sa asynchronous ay ito, this one, plus the calorimetry. So, tapos na tayo dun sa part 2. So, Wednesday ay asynchronous kasi ako ay may exam sa Lasal. Kailangan ko mag-review. Kala nyo kayo lang, ako rin. So, yan. So, on Wednesday, we are asynchronous. I will just upload the video. Please use the Saturday as a day to be with your family or to answer prob sets, no? Wag muna lumabas, especially if hindi naman kayo nag-work, no, or walang pinapabili mga magulang natin. Okay? So stay at home always unless necessary. Pero kung lalabas, use face mask, face shield, and alcohol. Don't forget alcohol. Okay. So again, asynchronous tayo for this last 3 topics for part 2. Last 3 topics for part 2 yan. Hindi pa tapos yung chapter 2 na actually, no. Maraming parts to, no. Okay. So let me go back here. Itong work week schedule natin. Wala tayong gagawin this day, holiday. Asynchronous tayo na ito. Mag-upload na lang ako ng YouTube video. Panoorin nyo na lang. Okay? So, magbibigay din ako ng worksheet, group assignment sa video na yan. Okay? And then on Saturday, dito wala tayong klase uli niyan. Okay. So basically, hindi niyo ako makikita starting from here to there. Kasi ito, async tayo. So YouTube lang ako. Tapos ito, ano na to? Mag-ano na kayo? Quiz, no? Quiz lang yan. Pero again, yung quiz na yan, hindi yan on the same day on deadline. No? You can still submit before finals. Pero, please, I request no na huwag kayong magkopyahan. Ako malaki tiwala ko sa mga bata. No? So, it's up to you if you will break that trust or not. No? Kaya ako wala akong pake. Kung mag-deadline man ako ngayon or sa susunod. Kasi ayoko naman na ma-pressure yung iba, especially yung mga nag-work. Ang hirap kaya magtrabaho ngayon. Okay? So in consideration for them, lahat tayo mag-a-adjust. Ang submission ng quizzes ay until finals. Pero it doesn't mean na doon kayo magpapasa. Okay? Magpasa na kayo kung may free time kayo. Okay? So ipopost ko yon sa Sabado mismo. Okay? So, wala tayong session for this until this. Makikita nyo na lang ako uli dito. Okay. So, yan. Dito nyo na lang uli ako makikita. Ito, sa YouTube mo lang ako makikita. Okay. So, with that, no, medyo mahaba-haba break natin for our synchronous session. I'll see you again next time. This video will be uploaded on YouTube for your reference pag nagre-review. Okay. So, I'll see you again and thank you for attending.